Hi, Bill here. This is one of the source files of my chess engine. It is called init.cpp. This is where one of the structures for the engine are declared and a lot of the functions that set up values for the game. So let's have a look. So we start off with an include file which has all my globals which are used across the different modules. Okay, so side and x side. These variables refer to the player to move, which is side, and x side, which is the other side. 50, that keeps track of how many moves have been made since the last pawn move or capture. So that's used in testing for the 50 move rule. Ply is a very important concept in chess engines. It's how many moves deep an engine is seeing ahead. So pi is a number of half moves seen ahead from the current position. H pi is short for history pi, and that's how many half moves ahead from the starting position of the game. Okay, nodes. Node refers to a position. So nodes are the number of positions the engine looks at. Okay, so that's done. That's just an array of 100 variables. That's used for sorting. Now these next two are very important arrays. Board 64 represents the chessboard. So the indexes range from 0 to 63 inclusive, and each refers to a square. So 0 refers to A1 and so on. So the board, each board contains either a piece or empty. The colour, again, is either white, black or empty. So these two arrays keep track of the information on the board. King lock is short for king location. So that gives the current square the white king and the black king are on. History. Now this is used for the history heuristic. So notice it's a two-dimensional array. One refers to every square on the chessboard. So each move has a from square and a to square. So what that means is whenever a move creates a cutoff, what's called a cutoff, the history value for that move increases. So if it's worked a lot of times, then there's a good chance it might work again. So we'll put it higher in the search order. So we add that to the sorting score. So the higher the score, the earlier the move will be searched in the list of moves. Table score. Okay, so that's the current score for both sides, based on the squares the pieces are on. Okay, so this is square score. So that's the score for both sides for each type of piece for every square on the board. So we'll have a look at that in depth. This is a very important part of the evaluation. This is so basically a knight in the corner is not worth as much as a knight in the centre. So there would be a lower score for a white knight in a corner than in the centre. Okay, so this will get populated later, and this will happen during the initialization, which happens before the game starts. King endgame, so that's the value of the square the king's on in the endgame for both sides. Pawn material, that keeps track of the pawns for each side. Now the way it works is this engine uses a value of 100 for every pawn. So that's a nice simple system which is easy to use. Piece material is similar. So that's a score in terms of 100 points per pawn for the pieces. So these are separate, pawns and pieces separate. It's important to know when the game is in the endgame, for example, and there are some values to knowing how many pawns the side has. Okay, so pass pawn, so that's the value of having a pass pawn on any square for both sides, and that has to be pre-set up before the game begins during the initialization. King moves. Okay, so this is a list of all king moves from any square of the board. So this is pre-generated for the game, so it's one way to make the move generation a bit quicker than otherwise. And the code's a bit easy to follow too. Again, knight moves are similar, so for every square on the board we have a list of up to 8 different knight moves. King moves. So we have up to 8 different king moves for every square on the board. So we've got this is a bit different, this one, because it's we'll come to how that is different. Okay, so move list. So in any position we'll have a list of moves. So the average number of legal moves in a position is 36, so we'll have up to about maximum of say 100 legal moves in any position. Now this is a little bit complicated to explain. So this is when we're looking at a line, we'll have all the legal moves in the first position, and at the next pile we'll have all the legal moves from the current move we've been looking at. This keeps track of the where in that branch of moves is the first move at that depth. But that will become clear right on. Game list. So this is okay, we'll come to that one. Okay, so this is just an array of characters which we'll use to display the moves. Sorry, the piece type. So notice we use N for knight, just like in chess notation, to distinguish the knight from a king. So we've got a pawn, knight, bishop, pawn, queen, king. Piece value. So this uses a very crude way of giving a value to the pieces. So a pawn's worth 100 points, and so forth. So it uses knight and bishop are worth 3, a rook's worth 5, queen's 9, and the king's worth 10,000. So the values of the pawn is 0, a knight is 1, bishop is 2, a rook is 3, a queen is 4, and the king is 5. So that's how the pieces are represented. Okay, so this is the starting colour for every square on the chessboard. So the number 6 represents empty, so that means it doesn't belong to either side. 0 is white, and 1 is black. And notice with these arrays, when the values are declared along with the array, this square here represents the A1 square. This is B1, this is C1, this is D1, and it goes all the way down to H8. So to make it easy to read, the 64 numbers are set out like a chessboard, even though they're upside down back to front, but that is a disadvantage. If we do it the other way, there are complications as well. So I've chosen to use A1 equals 0 and do it that way. Okay, knit pieces, so this is where the pieces are set up at the start. So at the start we have a rook, which is 3, then a knight, then a bishop, then the queen, then the king, then the bishop, then the knight, then the pawn. So that's how they're initially set up. Then we've got, sorry, that's a rook. Then we've got a row of pawns, then we've got some empty squares, a row of black pawns, and then the pieces. So these two arrays will be used to set the board up at the start of the game. So then we've got, now this is a useful little an array called column. So what this does is it fetches whatever column the current square is on. So if I want to look up, say, square number 9, which is here, it's on the first column or the first file. Likewise, we can fetch the row of, look up the row of any square on the board. Now, using these arrays, it uses a tiny amount of memory, but it is better than calculating them on the fly. In a chess engine, we want to make things as fast as possible. We've got flip. Okay, so now why we have this is we want to be able to flip the board, because what we're going to do is we're going to set up scores for every square of the board for every piece for white, and then they're going to be different in reverse order. So while having a pawn on the 7th rank might be really good for white, if black has a pawn on the same square, it's not much value. So that's for flipping the board, which we'll use later. Okay, pawn score. Now this is where you can change these. So basically it's saying pawns can never be on the first rank, so they have a score of 0. Now you can do all sorts of build into all sorts of things in these tables by giving the pawns on D2 and E2 a negative score. You'll prompt the engine to move those early in the game, and by giving a higher score, you'll then, for the bishop pawns, you'll deter the engine from moving pawn to C3, pawn to F3 too early, stopping the knight getting out. Okay, so you can see the two central pawns get high values when they get into the centre, so they get bonus getting pawns right in the centre. You get a value of 8 for the pawn being on a central square. The rook's pawns don't get a big value for advancing. Notice the knight's pawns and the bishop's pawns, even though they are stronger on the middle files, they do not increase in value until they get to the 6th rank. One of the reasons of that is to stop the engine moving pawns for no good reason. And the idea of having different values for the rook, knight and bishop files is to encourage the engine to capture towards the centre. Okay, because the central pawns have been slightly more valuable. So when we get the pawn to the 6th rank, either it's passed, which means it's quite good, or can form a wedge into the opponent's position. So you do get a bit of a bonus for advancing the pawns up that far. Okay, and when you get to the 7th, you get a bigger value again, and you can't have a pawn on the back rank, it would become a queen, so 0s for that rank. Okay, so what will happen, that would be the score for white, and black will have those scores flipped. Knight score is similar, so we've got very poor scores for the knight in the corner. The knight in the corner on the opposite side of the board is even worse. It's a whopping -1.5 pawns, because in practice it can be hard to get out of a corner. Knight's a little bit better when they're near the corner. Knight's a negative for being on the back line or on the edge. When they hop in towards the centre, into this zone of 16 squares, they start getting better values, and notice they get a even better value when they're right in the middle on the 4 central squares, and they get reasonable values near the centre. Okay, so bishops. Bishops are again pretty lame on the back ranks. They get a negative score for being on the first rank because they get in the way of the rooks, and also they're not developed if they're on their starting square. Not particularly good scores for the side, but I'd probably rather have a bishop on, say, h4 than e1. And gradually they get stronger as you get towards the centre. Other things being equal, bishops are better in the more central squares. A rook. Okay, so rook gets small scores for squares. A rook gets a bonus for being on the first rank, because it can never get in. No pawns can ever get in the way, and it can move to open files or half-open files quickly. It gets a bonus of being on the central ranks, just because they're more likely to be open, particularly the engine's moving its centre pawns, as it will. and rooks get a bonus for being on the 7th rank and a bonus for the 8th rank. Everybody's heard about the 7th rank being good, but the 8th rank is also good. But the real value of a rook comes when you put it on an open file, which is worth 20, but you don't know about that until you know that's going to be different for every pawn structure. And you get it, and the rook gets a bonus for a half open file. Queen score, not a particularly high scores for the queen, but it's negative for being on the 1st rank, and gradually gets better towards the centre. King. King is ideally placed in one of the 4 corner squares, and big bonus, big negative for moving from its starting square to D1 or F1 because it forfeits castling early in the game. And these scores will value after the king has castled, because that will change the scores, the king squares. And so you can imagine this really is applying fairly early in the game. And imagine if the king gets to the 3rd rank or more, there's quite a massive reduction in score. The scores aren't super high because you never know, sometimes the king will come out and survive winning pieces and so on. But yeah, you probably could up some of these scores. Okay, king in-game score is pretty much the opposite of the middle game and opening score, which is the previous table. So the king wants to rush out towards the centre as fast as possible. Pass pawn. Okay, so you can't have pawns on the 1st rank. Pawns, and doesn't get a bonus of having the pawn on the 1st rank because it's really got to start moving to be worth anything. Okay, so we get now. Okay, so sorry. Now it's not giving anything for the 7th rank. Now I think that's because the pawn on the 7th rank is always passed, so the pawn gets the score from the pawn table, from the score table for a pawn, not from the pass score. So pawn only gets this bonus score if it is in fact passed. So 0 for the 1st rank, 1 for the gets 8 for the first couple of ranks. There's no difference because the pawn can do a double move and jump straight to the 4th rank. So it's going up fairly steadily. Gets up to 60, which is about 2/3 of a pawn on the 6th rank. Okay, so now we're setting the table. So what it does is it populating the score, the square score tables with the scores from the other tables we just looked at, plus the values of the piece. Okay, now for black we flip those, so we get the reverse square for each out of the square table. Okay, so we populate all our tables. Okay, so this is a function for setting up variables for a new game. So we fill up the chessboard with the starting colours and starting squares. We set the side to white, the other side to black. We set 50 back to 0. We set the ply and the H-ply, the first move. We set the king locations to where they are, and we set the castling flag. So here we've got the castling king and queen side for both sides. So they're set to 1, meaning it's possible. When they're set to 0, they are not possible. New position. So this is done at the start of every move. Okay, so we reset the values of. So this is done. Yeah, just once every move. So this is calculates all the scores for both sides, and it sets up the board and the colour, makes sure all the stats correct. So it's current key and current lock, they're used in the for maintaining the hash table. So every position has its own hash code, which alter every time a move is made. Okay, algebraic, this is just for displaying a move, just for mainly for debugging or output. Ditto for alg1 and alg2. Algebraic, this is a rather crude way of doing it, but just it could have been a shortcut for doing this, but this just prints out a string representing a square. In the case, if I want to print out a square, show all. This is for use for debugging. This just prints out all the legal moves and so forth. Okay, so Z and Z2 also, they're shortcut keys for show all and show all too. So this prints out mainly debug information, get the best. Okay, so this is an important one. So what this does is it this is for so the moves can be sorted. So what this does is when you display this list of moves, it puts them in the sort order. So you can see how well the engine is sorting the moves. Okay, set moves creates the lookup tables, night sign pieces. Okay, so this is pre-calculating the moves for the tables for the different types of pieces. Okay, so you don't need tables for pawns. It's easy to calculate a pawn move. Okay, so they'll be used to generate moves, captures, and attacks. Okay, so what we're doing here is so provided the moves are legal, we're going to work out the knight moves by adding something to or subtracting from the square number. If we're too close to the edge of the board, we won't do it. It does that by using the row and column lookup tables to see what row and column the current square is on. So we work through all the squares and set up all the knight moves for both sides. The knight moves that are possible from each square. Okay, so this one does a similar thing with the king moves. So it adds or subtracts 1, adds or subtracts 8, 7 or 7 or 9 to produce lookup tables for the king moves. And that's about it for the init.cpp. So all these functions are used at the start of each move. They're not, or the start of the game, they're not used during the main loop. Okay, so there's 7 other source code files and 1 header file, and thank you for watching.